Hey everybody, I'm very excited today to talk to you about TypeScript, about types basically, and how can you apply them to real-time programming. So I'm gonna go over a fun example, which is a multiplayer game, and let's get to it. So who am I? First of all, my name is Fernando Alvarez. I'm Ecuadorian. I'm married, 2 kids, 1 cat. I have more than 10 years in the industry. I might not look very old, but I'm kind of an old guy. I'm a developer at Stack Builders right now. It's a consultancy that specializes in functional programming. I'm a part-time musician. My nickname is Kui, which is guinea pig. There's a fun story behind that, but I can't tell you because it's the script for my origin story movie, so I won't tell you. All right, so I'm one of those weird guys that wakes up at 4 a.m. every day because I'm this morning person that is more effective in the morning. And yeah, just as a trivia, my favorite movie is The Goonies, and you can follow me on those social networks below. So let's start it. And this image is kind of what started it all for me. This QBasic image. I remember my dad bringing a computer and just I had QBasic on it, and this QBasic had some interesting code examples there. One of them, and I don't know if any of you remembers this, maybe the older guys remember it, but there was this game called Gorillas.base, which was about 2 gorillas flinging bananas at each other. You would just input the angle and the velocity, and they would just throw the bananas at each other's. And if you I don't know, hit the other gorilla, you get points, and that's I guess what the whole game is about. But I think this is what I was put into. I had this code example, and me I was a little caveman, as you can see at the bottom left of the screen. I was just perplexed of that you could actually change code and or change some letters or numbers, and you can modify things in the program, which was really nice at the time. So in this presentation, I'm gonna just make a port of that game using TypeScript, using WebSockets, and we're gonna just talk about some of the techniques and some of the things that I've done to achieve this. So what's on the menu today? So first of all, we're gonna go and check Socket.io, which is the transport library we're gonna use, and we're gonna check its types. Just talk about some things that could go wrong with the current types. It's not that the library is badly implemented or something like that. It's just that it makes. We're gonna discuss a bit more about this. Then we're gonna see how we can implement the server and the client, and then we can see the code in action, right? And no dessert. We're cavemen and we hate sugar. The keto diet and all of that, you know. Okay, so once upon a time in the loosely typed cave, we had this library, Socket.io, which had these type definitions. So when I started with this project, I kind of noticed Socket.io has some loosely typed definitions, which makes sense in the from a library standpoint, you know, because you would want to allow anyone to use the library as they would want. So when you are listening for an event, so we have 2 functions, on and emit. On, you listen for an event that's happening on the server side, and or that another client broadcasted. And with emit, you can broadcast these events, right? So it makes sense that the listener has a callback type as function, which is which is pretty convenient because you can do anything with the incoming message. And the same in the case of emit. When you emit something, you would want to emit any arguments or any type of arguments that you want, right? But this kind of gets problematic a bit when you are actually implementing safe code, safely typed code, right? This is an example that will compile. There we have our compiler Caveman, which he's gonna just check the types and say, yeah, the object, the throw data object, has angle and velocity. Those are correct, and yeah, they're numbers. So you can do this fancy math with numbers function, and the thing is that you kind of, on the back of your mind, you have to know the structure of the object that's coming in the socket, right? But what happened if I sent a couple strings? Instead of sending numbers as an angle, as a number, I would send 35 degrees as a string. Then my compiler wouldn't compile, right? Wouldn't type check these correctly, just because over the socket we allowed an any type, and the fancy math with numbers function is requiring two numbers. So what can we do here? And the answer is just calling TypeScript man, or in this case TypeScript caveman, and he's just so happy, and that is because he won't see this error in production if we ask for his help. And also, he's as a trivia, he's wearing some awesome socks from last year's TypeScriptConf. Anyways, we're gonna go back to the village of types and just check what can we do with this library, and how can we improve our chances of not getting runtime errors, right? Let me just grab some water. All right, so this is our vanilla JS socket server. This doesn't have any TypeScript on it, and this is just basic boilerplate from Socket.io. But as you can see, I use some callbacks with some data, and this is not type safe because the function signatures and the function types tell me that I can actually have a function that receives anything here, and I can do basically anything with this and emit anything through the socket, and this is the case for all of the operations that I have. You can see that I have a typo here actually, but it's okay. I'll edit it later. And as you can see, I kind of have to write this many times. So this is a common point for errors. This is a point where us as programmers would commit a lot of errors, just because there's a lot to type, right? And we don't have type safety as well. So, and bear with me on this slide. I know it's a lot of code. I'll try to go over it in a good way. So what we can do, just to ensure a bit of safety there, we can create a type called socket event, which would be the first argument to our on and emit functions. Remember that it was a string that was event. So right now we're gonna use a sum type here and just allow a few strings that can be sent to that function, right? And I'm gonna go and create an interface called wrap server socket, which has this T, which the more seasoned programmers we have this in several languages are generics. So it means that I can generate this type based on another type, and this one is gonna be an object. The wrap server socket is gonna be an object, that has a string as an event, which we could actually change this and use socket event just to keep things tighter. I'm gonna just do this right now. And we have the callback, which is what we're gonna execute after receiving one of these events. And this is gonna be a type called socket action function, which is also generic. And this one is defined here. What it means is that if I wrap this server socket with a generic, I can put this type down onto all of the subtypes and have this function correctly typed. So the message is going to be of type T because the wrapped server socket is of type T. If I create a server socket of type string, I could only have a function that has a string argument and returns nothing, right? So on the right side, I'm gonna just go over the basic boilerplate we had before. It's just these first few lines, and just to make it a lot smoother and a lot easier to register new events, I'm not gonna do what I did in my last slide, which is socket on something and then broadcast that event. What I'm gonna do is I'm gonna store those in an array, and this array is gonna be is gonna have objects of a certain type, which is wrapped server socket. This one that we got, right? And we're just gonna iterate over it, and for that, to create those objects, those little objects, we're gonna add a function that's called create socket, and this create socket receives an argument. So this basically what it does is keeps everything wrapped in a nice little object here, and in the end, this function returns an object with the socket event and the callback, and this callback is type safe, just because what we talked about. It's because it either is an action, which is of type socket action function, which in turn would use like the concrete type here that we pass when we create the socket, right? And then we can also have this broadcast event just as a fail-safe measure in case we don't want to send a callback here. And this, yeah, as TypeScript man says, this might seem a lot of code, but it's really easy to maintain, because when I want to register a new event on the server, what I can do is just add one of these lines, create socket with the type that I want, and then add the action here. And when I want to use it, that will just get picked up by the server bootstrapping, right? That we're doing here. All right, and on the client it's a bit similar here. So we're gonna have a listener callback, which is a type function, right? A function type, which I'm gonna send a generic argument, and it tells me that this type is gonna be a function that returns a void, and that returns nothing, right? And I'm gonna also create a new type that's called data socket, which receives this generic argument, and yeah, as you can see, all of the this is gonna be an object similar to what we had in the backend part in the server. So we have three functions here: emit, on, and off. I'm gonna add the off function just because it's a good practice just to clean up your sockets after using them and not leaving them open. And as you can see in emit, you have this function that receives data. As we remember the concept behind the sockets, emit is just gonna send a message through the network. And this message is going to be typed as T. because we created the data socket with T, or with string, or with number. So this one would only allow a number to be sent. The same case for on and off, but these receive functions, and these are of type listener callback, which is this little type we have here on top, and we would just keep them safe because they are using the same type as data socket, right? And I have a similar function here that's called create socket, similar to the one that we had in the backend. And this one receives an event, which is a string that says, here's the action that you're gonna do with the socket. So in our case, the action would be, for example, throw bone, because this port of gorillas.base is going to be cavemen.base, just because I found these little nice little caveman theme assets. I'm gonna leave the link for you after that. They're free to use. So and yeah, our event would be throw bone or throw banana. These were gorillas, and it would return an object typed with data socket T. And when we use this, you're going to see that it keeps everything type safe. And this, for this, I'm going to call just 3 helper functions, which is emit callback, on callback, and off callback, which all receive the event that we're sending from the top. And here's a here's a really nice thing from JavaScript. Yeah, as you know, JavaScript has higher order functions, which allow us to send functions to another function as arguments, or return a function from a function. So in this case, we have 3 functions that we talked in the previous slide. Emit callback, which receives a string, which receives an event, which is a string. We could also type this as a socket event, just to keep everything tight and not allow anyone to send anything. They're going to be, since we are using only these functions from the create socket function, then they're going to be type safe, because they're going to inherit the type from or the events from the outer function. But in this case, it's a good measure to not put string here, but the actual sum type that we have for our events. And in this case, we're returning functions from each one of them. So in the first case, we're returning a function that's received a data of type T, because we want to keep it type safe. Sorry, and we're gonna emit that through a socket. This is the standard socket AO function, and we're gonna send this event that we got from the parent function, and we're gonna send it with data, which now it's type safe because we're using generics. Same thing with on callback and off callback. So as you can see, we can not only type variables or something like that, we can also type functions, and that I think that's a great thing that that TypeScript has. We can just give this contracts and have this to ensure type safety across the whole application, right? And here's how you use it. So we create a constant called socket throw, and this is going to be the type data socket with throw, which is the type we're going to send through the socket, or we're going to receive from the socket. And our action is typed as socket event here. I just call create socket as a function. I use this throw or throw bone or throw banana or whatever you want to call it, which is a socket event typed action. So you can't. So you need to specifically define which actions you're going to allow to be sent through the socket, and this you do by adding it to the sum types that we saw before. And you kind of, as you can see, we've kind of wrapped the behavior of our sockets of our standard library functions on kind of a bigger package, which is a bigger object, which ensures that we kind of keep everything type safe. And all of these type check successfully. When I do a socket throw on the IDE, in this case I'm using Visual Studio Code, it helps me a lot with what can I receive here, because the IDE tells me that when you execute the on function on this socket throw object, you're going to require a data type of throw, right? Instead of just getting a random object or an any type. And I can also emit things from here, and it will type check for me that I include origin, angle, and velocity, because those were part of the throw type. So you can see how nice it is to just wrap libraries, and wrapping them with TypeScript just keeps everything type safe. So my super recommendation here is wrap it up. When you have an external library that doesn't have that is kind of more generic and can be used for many things, and you have any types, and you see that it makes sense that this library has an any type, you can just wrap it up and just tailor it to your needs and keep your code safe, which is pretty good. And also, I'm gonna talk about a few other things where TypeScript could be helpful in game development. So in general, you have a hierarchy of game types in when you're developing a game. In this case, this is let's think of a platform game where you would have a character, the player, the NPCs, the bosses, and all of them live in this tree structure of types. So they all inherit from character. Then you can have the player, and you have TypeScript man and TypeScript girl, and then enemies you have the bat, the tiger, the dinosaur, which could share some common things, but have also some specifics between them. But we want all of them to inherit some base property from character, right? Like the sprite, or like the size, or the velocity, or whatever you wanna do. So for that, TypeScript gives us type extension, where you could have the character and then extend from that interface, and just add different things. There you can see a pretty clear example. So you have character, you have enemy that extends character, and you have bat and tiger who both extend enemy. And you can kind of do some custom behaviors for those, for each of them, right? And you can do this using type guards, which is a really nifty feature from TypeScript. So what you can do is just check if the object that you're sending is, you can have, this is kind of a trivial example, but you can have an isBat function, and type it as and type the input parameter as bat or tiger, and when and you're gonna code your logic, and then you're gonna determine in runtime if this one is a bat or a tiger, right? So you're gonna make the bat screech and the tiger roar. This is a really basic and silly example, but you kind of get the point of coding a specific behavior with this type guards, right? And I would also recommend, if you're doing a full stack TypeScript game or application or anything that has to go with in the domain of a real-time application, just because you want to keep the types consistent between the backend and the frontend, you can just go and share your types. And this is easier when you have a full stack TypeScript application. So what you need to do here is just on tsconfig.json, you can configure the paths of your front end or your back end, and and you can import them really easily without doing some relative imports and weird stuff there. You can just modularize this. And I recommend doing a separate directory called contracts where you can share your types. In this case, for example, I am sharing the socket events, the socket event type, which is throw bone or throw banana. And I'm also sharing the models, my data models, because I need to use the same structure for a player on the front end and the back end. And this is very convenient to do it in a contract directory, right? Okay, so let's see this in action, the actual game. This one is the screen for player 1, and this one is the screen for player 2. They're just being differentiated by URL. Player 1 can throw a bone, and you can see it right on player 2's page or screen. And you can just go on and alter the values here. And what's happening behind the scenes is that we are sending just the socket event for throw bone, which tells the other players, hey, this player threw a bone with this angle and this velocity. The good thing is that it's all type safe here, and every client can just react to those different to those messages in a different way as you want to put your game logic. And just as a quick overview of this, so we just need to wrap stuff like it's Christmas, like you would wrap a Christmas present. If you need to add types to something and you don't have a way of doing it on the actual library, you can just wrap it, and it's an easy and nice way to keep your types tight. And it's also in some cases a good practice to have like a wrapper around the libraries that you use, because if I use directly, if I use Socket.io or any socket library directly, I would need to change my code in a lot of places, and that hurts a bit maintainability of my application, right? And also use generic and function types. Generics are your friend, and you can use extends to model your hierarchy, and use type guards to kind of make specific behaviors for your different types. And finally, share the types between the backend and front end. That will definitely be a really great thing that you can do in full stack TypeScript applications. And if you don't have full stack TypeScript applications, there are a lot of tools that kind of transform from I've worked, for example, with Haskell and doing transformation between the Haskell types and TypeScript types. So you run a Haskell script, a Haskell program, which generates the types on TypeScript and keeps both types in the backend and the front end consistent. Right? And yeah, that's kind of the end of it. So I'm really happy to have shared with you a few pointers. You can see the code on that GitHub repo there, and you can see those fun assets for Caveman, and there are other assets that are done by this person here, which I'm thanking in this presentation. So yeah, now go and add types to everything. It's a good practice. It's a good thing you can do it, and you can do it gradually, which is really nice always. And yeah, I guess that's it for me. Stay at home, stay safe, and thank you for your attention. Bye-bye.